Excuse me. Are you busy or not?
No, fine.
So we did this last class, but I was confused. Is it -4 or -14?
-14.
Because -4 gives you that answer, but I tried -14 and gave me a totally different answer.
No, it has to be -14, right? If you -5, -14, then they give you something close to -10.
Okay, because when I put it in a calculator, it gives me this, but it gives me -20.
You must use the calculation
Okay.
wrong. So in the actual practice last, so you can check it. So this has to take -14. Okay, it's always -14 for the on back calculator KB from KA or vice versa. Okay.
Thank you.
Yeah, so practice it. If it doesn't work, then come to me. Okay.
Oh, they have donuts with it. You want? Can I take physics lab? Wait, what's all these yeah, because you have to make some. So it's you're getting nature. You're smart at that's not amazing as far. Yes. I mean, I just did. I had fun. Use the coach lab. I'm trying so we did the narration. I like we did a calibration. You only just yeah, I don't. Oh yeah, that's like more about the part that you have to figure. Yes. At the artists, I don't have anything all like really use paper like a giant like instead of stick. I just they don't give that's yeah. Also, I just those directly so they're based on stuff like yeah. That's why I do writing. Writing is okay, so any questions before we get started? So I'll have 8 more questions to go today. Okay, so everybody feel okay now for your midterm too? All right, so what's the most important thing for midterm two? Is that you need to know what solution you have, right? So let's practice that a little bit more before I get going into the final 8 questions today.
Okay, so the things I want you to do is pretty some simple things.
Okay, so it's kind of a quick refresh about the things we have went through in the first midterm review. Okay, we covered a few important concepts, right? One thing is actually the conjugated acid and base, right? So I'm pretty sure you're going to have one question like this in your midterm too. So if you know how to do this, at least you got 1 point, right?
We only have 28 kids today.
Okay, so the question asks you what is actually a conjugated acid of H2, or HS minus, right? So to find the conjugated acid, what you do is actually in H plus to the original equation, right? So then maybe you have H2S, right? And because that positive charge neutralizes the -1, therefore you have H2S as your answer. So the answer is actually number 1, okay?
Okay, so now we're going to actually
make a judgment what kind of solution we have, right? Which is actually one of the most important things you need to do for every single question for chapter 13 and 14. Okay. Okay, so I hope your response is instantaneous, okay, because you need to know how to actually those judgment now. Okay,
So this one is actually especially easy because it tells you this is acid already, right? So you should know formic acid is actually not B7, it can only be the weak acid. Okay, so answer will be C. How about this one? Okay,
so the answer will be buffer, right? So the way you actually know it is buffer is because it contains two species. One is a CH3COOH. The other one is actually CH3COONA, right? And CH3COONA will be associated with your CH3COO minus, which is actually a conjugated base of lactic acid. Okay, since right now I have both lactic acid and its conjugate base coexist inside a solution, therefore it's a buffer. Okay.
how about this one?
Okay, so the answer will be D, weak base, right? So how do you know it's actually weak base? So if you read the question carefully enough, you'll see the substance you have is NaCH3COO, right? And then you look at the question at the very end, you see it's Ka for the CH3COOH. Okay, so you know these are not the same substance. Okay, the previous CH3COOH is actually a weak acid because you have the Ka, right? That means actually the other species presented inside this question will be the conjugate base of this weak acid. Okay, therefore you're going to have a weak base solution. Okay, so this is actually a critical step that you must become a master. Oh, one more. Okay, so the answer will be a weak acid, right? So it's similar strategy we're going to take, right? So if you read the question carefully, you got two substances inside your solution. Okay, so the one with Kd turns actually the weak base, right? Yeah, but the one that got passed inside the question is actually it's the other species. Therefore, that one has to be a conjugate acid of this weak base. Okay, so we reach the acid solution. Okay, so the reason we emphasize, I guess I can repeat it myself so many times now for so many weeks, right? But I hope you see the power of that, because once you recognize what solution you have, you will know how to actually do the calculation quickly. All right? That's all for this. Oh, one more. Okay, so this is actually only question today that we have multiple opinion now, right? So how to actually predict what kind of solution that you have and what the pH will be. Okay, so this actually will be the first question I want to went through today. Okay, so it's exactly the same question. Okay, so how do you actually make a prediction for this? Because I think that is actually the only problem that we don't have consensus, okay? So apparently the question is actually want you to know the pH is larger, small, or equals to 7, right? And the data that you have, okay, let's read this things carefully. It says you have an aniline with a Kb, okay?
if 100 ml 0.5 N of aqueous aniline solution is mixed with hydrochloric acid. Okay, so we want to actually first analyze that. What's this? It's a strong acid, strong base with acid with base. With base, right? So I always use A minus to represent my with base, right? And it's mixed with HCl, right? Hydrochloric acid, which is a strong acid, right? So I know I can write H plus for that. Okay, so I can write my with base. I have 0.5 M, 100 ml. My strong acid, 0.5 N. Also the same 100 milliliters, right? And then these two will mix together. Okay, so I can actually write some equation to help me think about this. But everybody finds this equation with base interacting with strong acid that give you the conjugated acid. Okay, then you want to analyze. Okay, when you have a strong acid or strong base, it is going to kill. In this case, you have strong acid, right? It's going to kill all the base, right? You need to know. You need to play the survival game here, right? So to provide the survival game first, you need to actually calculate the moles. Okay, so this will be 0.5 times 100 milliliters. That give you 50 millimoles. Similarly, for your strong acid, it's also 50 millimole, right? So I put 50 here, 50 here. Okay, and they are going to play the survival game, but they have the same amount, right? They are going to consume each other 100%. At the same time, produce your conjugated acid, right? So at the end, it's actually you don't have A minus, you don't have H plus, but you do have a bunch of HA. Okay. So that tells you what? It tells you have a weak acid solution, right? Since there's a weak acid solution, so you have HA solution. Therefore, the pH is going to be lower than 7. Okay. So any question for this? Okay. So I actually talked to many of the students, okay. I realized that one thing that students feel confused is that where should I actually write equations? Right? How do I know I can write this and do this analysis myself? Okay. So here's actually a tip. When should I actually write this equation? When you see your solution mixed with strong acid or strong base. Okay? You should notice that all the equation I write will always involve either strong acid or strong base. Okay? And that's the time you want to actually write it out and start putting your moles for the molecules. So you know who's going to win for the survival game. Okay? If you have a weak acid with base that mix together, okay, in the context of CHEM1312, you will always be covered. Okay, so you don't really care, you don't even have to redo this. Because the weak acid base you're going to get, it has to be conjugated acid base. Okay, so the question you're going to encounter for your midterms, if every time you see something is mixed with strong acid or strong base, okay, that's the time to write out the equation to do the survival gain analysis. Is that clear? Okay. So
Once you write this out, make sure you use moles or millimoles to calculate the amount. Okay, to compare two section mole, two section line. Okay, so that you will be actually really see what the true color of the solution. Okay, is that clear? Okay. So that's actually how you solve these questions. Okay, then we come to the chapter 15, okay, the solubility chapters. Okay. So this question says at 25 degrees C, the solubility of barium carbonate is a certain number. Calculate the value of KSP at this temperature. So your Q is want to figure out what the KSP is, right? Data. Okay. What is actually the salt that you have? Barium carbonate. Okay, so let the insoluble salt. Okay, so every time when we're talking about the solubility, you must write out the dissociation equation of less insoluble salt, right? So once these things dissociate, it will become Ba2 plus CO3 2 minus. Okay. Everybody have this? Everybody understand how to write this equation? So how do you know you should write in this specific way? If you look at the BA, okay, if you check out your periodic table, okay, BA is one of the 2A element atoms, right? So once you dissociate, it always carries positive two charge, right? And then carbonate. I asked you guys to memorize a few polyatomic anion, right? Carbonate is actually one of them, CO3 2 minus. Okay. So if you know the charge, then you should be able to write out these things without any problem. Okay. So if you can write this, then you should be able to write your KSP is going to equals to Ba2 plus first power CO3 2 minus first power. Okay. Then it says the solubility of this insoluble salt is 9 times 10 to the negative 5 mole per liter. Okay. Then what you want you to do is actually you look at these things and write out once it dissociates what the concentration will be for this and that. Okay, because the ratio between your insoluble salt to the Ba2 plus is 1 to 1, right? Therefore, you know this will be S. Similarly, this will be S as well. Therefore, to calculate your KSP, it will simply equals to Ba2 plus concentration S to the first power times the CO2 minus concentration to the first power. And now with S squared, right? And then we know that S is 9 times 10 to the negative 5. Square of that will give you 8.1 times 10 to the negative 9. And that will be your KSP. Okay. It's very simple, straightforward calculation, but that's actually one thing to be careful. First, the given solubility has to be a molar solubility, cannot be a grain solubility. Okay, so if you look at this, we have 9 times 10 to the 5. Okay, pay attention to the unit. The unit is mole per liter, right? That's the unit for molar solubility, okay? So make sure you use this. This one, okay, is the molarity, right? Let's solve for the molar solubility. You must use molar solubility to calculate your KSP, okay? So it's very simple question, right? Any question for this one? Good. Okay, next one. Okay, so this question says 1 liter of saturated solution contains 0.0167 gram of this salt. Molecular weight is like that. What's the KSP? Okay, it's very similar questions. Okay, so Q, you want to actually calculate your KSP, right? And then data, it tells you this actually tells you the solubility. So it's not like the previous one, right? This one can tell you the solubility is a given number, right? But here, you say in a way it's not very clear, right? It says 1 liter of saturated solution contains certain amount of your insoluble salt, right? So that's so-called the grain solubility. Okay, so it tells you the grain solubility is that I can dissolve 0.0167 gram in 1 liter of the solvent or 1 liter of the solution, right? So this is actually not something that you can use because when you calculate KSP, you must use the molar solubility, right? So to convert the grain solubility to the molar solubility, what you do is actually instead of using grain, into using moles, right? So you will do 0.0167 divided by the formula weight, 78.1. So this one will actually give you the mole, okay? And then volume is still 1 liter. Okay, so once you do that, you will be able to figure out your solubility is going to equals to 2.14 times 10 to the negative 4. Okay, so then you get back to the same situation that you had like the previous questions, right? So you can actually write out the dissociation equation now. Okay, CaF2, once they dissociate, is going to produce Ca2 plus, and then 2F minus. Okay, so this is actually the part that you must know how to actually write it. Okay, and then the KSP can then be calculated using the Ca2 plus to the first power, F minus to the second power. Okay. Once you have that, then you want to analyze how these things can be expressed in terms of the solubility. Okay. So you know the solubility of the CaF2, they say it's S, right? Then you're going to produce the much Ca2 plus, or you can have 2 equivalent of F minus. Okay. That means your KSP is going to equals to S to the first power, 2S to the second power. This will give you 4S cubed, right? Then you just replace this solubility with this term.
Okay, then you will be able to get your give you the wrong number. Okay, so if you do this calculation, it's going to give you a number of 3.91 times 10 to the negative 11. Okay. So the second question is actually basically the same as the previous one. The only difference is that it gives you the grain solubility, right? So it's testing you whether you know you need to use the molar solubility to calculate KSP. Second, equation-wise, they are slightly different, okay? Because in the CaF2 case, okay, one of that is going to produce one Ca2 plus and two F minus. Therefore, when you actually write out your KSP in terms of the solubility, it will become 4x cubed. Okay, so those are the things that you need to be careful to get the correct numbers. Okay. Any questions? No, but next. Okay, so this is actually another typical question you are going to encounter in your midterm, right? So this is comparing the KSP and QSP, right? I said there's actually only two possibilities. One, KSP larger, QSP larger than your KSP, you are going to precipitate. Okay, if smaller than you don't, there's only two possibilities. Okay, no other combinations. Okay. So it asks you to know, are they going to precipitate, right? Data. AgCl is actually an insoluble salt, right? It's going to dissolve into Ag plus and then the Cl minus. Okay. So the KSP for this is going to equals to your Ag plus first power times your Cl minus first power, and it's going to equals to 1.6 times 10 to the negative 10. So that's actually your KSP. Okay. Then in the question it says, I want to mix two other substances. Okay. So this is actually a very standard structure for this type of questions. Okay. I give you a KSP of an insoluble salts. Okay. Then inside the question, I'm going to write the other two salts. Okay. And actually whether precipitate will form or not. Okay. There will always be a structure like this. Okay. So what you will need to do is that the other two salts will actually provide the ions that's going to form the precipitate. That's going to form your insoluble salt, right? That means one of the salt is going to give you the concentration of your Ag plus. The other one will give you the concentration of your OH minus. Okay, so what you need to do is actually try to figure out what the concentration I can get from my Ag plus from one salt, concentration of Cl minus from the other. Okay, and then once you get those numbers, then compute the QSP. Then after that, compare your QSP to KSP, and you will know whether the precipitate will form or not. Okay, so in this specific case, which one is going to give which salt? You have two salts. One is this, one is that. Which salt is going to give you the concentration of Ag plus? AgNO3, right? So can you actually just look at this and tell me the Ag plus concentration from this salt will be what? Can you see the Ag plus concentration from this salt will be 1 times 10 to the negative 1. Okay, the answer is actually very simple because you can see less salt. This specific formula only contains one Ag element, right? Means that once we dissociate, it's going to produce one Ag plus. Okay, so if they give you the concentration of this salt, then you should be able to write out your Ag plus is 1 times 10 to the negative 1, right? Then you go to the next ions, right? In this case, Cl minus. If you look at this, it gives you the concentration of CaCl2. Okay, how many chlorides ions can this species generate once it dissociates? 2, right? Therefore, you should know the Cl minus concentration should be 2 times 10 to the negative 9. Okay? Once you have this and that, then you can always calculate your QSP, which will equals to 1 times 10 to the negative 1 times 2 times 10 to the negative 9. This will give you 2 times 10 to the negative 10. Okay? Then you want to actually compare to your KSP, which is 1.6 times 10 to the negative 10. Okay, so which one is actually bigger? QSP, right? Since your QSP is larger than your KSP, therefore, you are going to see the precipitated form. Okay? So any questions for this? Okay, so let me recap the things, okay? So every time for these questions, okay, it asks you whether the precipitate is going to form or not, right? You know you want to actually compare your QSP and KSP. And the solution is only two, right? QSP larger than KSP, precipitate forms. Otherwise, it won't. Okay? And to calculate your QSP, the question will always give you the other two substances. And each of them will contribute one of the anions and K ions, one of the ionic species inside your solution for the insoluble salt. Okay, so you must actually know how to calculate the ionic concentration from those two salts. And from there, you compute your QSP and then compare that to your KSP so that you will know whether you are going to have the precipitate form. Okay, so that's actually the basic logic for these questions. All right, next one. Okay, so this is actually another type of questions that you're going to encounter very often, right? We call it common ion effects. Okay, so if you read this question very carefully, it says, what is the solubility of the insoluble salt, which they give you the KSP as well, in a certain concentration of the other salt? Okay, so currently the question is actually to calculate the solubility of your insoluble salt, right? Then every time you encounter this question, you always want to write the dissociation equation. Okay, so this is exactly the same equation we just went through. Okay, and it tells you your KSP is going to equals to Ca2 plus F minus square equals to 4 times 10 to the negative 12. Okay. And then again, if you have another salt, right? So the other salt will be a soluble salt, and it must contain one of the ions in your dissociation equation. Okay. So if you look at these salts, you have NaF, right? So which
species this guy's going to influence? It will be your F minus concentration, right? So it says you are going to have 0.035 m. This means your F minus concentration after you dump in this guy is going to give you that, right? Therefore, you know you're going to have lead to start with. Okay? And then you want to calculate the solubility. Okay, so the solubility of this, let's say it's actually S. Then you know the F minus coming from your insoluble salt will be 2S. Okay. Therefore, this will be the final concentration of your Ca2 plus and F minus inside your solution. And your KSP should equals to this first power times 0.035 plus 2S squared. And this will give you the value of your KSP. Okay. So another thing, another very important concept that we should have for chapter 15 is that because the equilibrium constant is so small, okay, therefore the small x approximation will always be valid. Okay, what I mean by that is that after you compute all the things, once you get your solubility, that solubility will be so small. Therefore, compared to this guy, this is basically negligible. Okay, so you can write this as, okay, so you go from here to here using the small x approximation. Okay, and then this will equals to your KSP. Therefore, you know your solubility will simply equals to divided by, and this will give you a value of 0.035. Okay, so this is actually how you solve a question like this. Okay, any question for this? No question at all? Why do I what? Why do I do the small x approximation? Okay, so look at the s. How small is it? Just look at power, 10 to the negative 9, right? Look at that, 0.035. Okay, how many order of differences are there? So that's actually 10 to the negative 2, right? 0.035 is 3.5 times 10 to the negative 2. Okay, that is 10 to the negative 9. There are 7 orders of magnitude differences. Okay, then this one, if you do this calculation, if you don't do the small x approximation, okay, the number that you get over there, it will be actually 3.2999999 times 10 to the negative 9. Okay, so it doesn't really influence your solubility. Okay, but calculation-wise, of course, you can just still solve the equation on the top. Okay, you don't throw away the 2s inside the parentheses. You can still do that. You can still get your solubility. Okay, but the number you get is going to be very, very close to the number I get over there. Okay, but the problem is that if you actually solve the quadratic equation, that's forever, right? But if you do the small x approximation, like easier. So take the easier route. Does that make sense? Okay. So the small x approximation is actually something convenient for your calculation. because it will still give you a very accurate answer. Okay, but it will only be true when your equilibrium constant K is very small. Okay, so when I say very small, typically smaller than 10 to the negative 4. Okay, but if you look at the question here, right, it's 10 to the negative 12. It's extremely small. Therefore, small x approximation will always be applicable for the chapter 15. Okay. Any other questions? Okay.
Okay, I want to go through this first.
Okay, so this is actually a very similar questions like the one we just went through, but it asks you the solubility. It asks for the actual solubility.
Yeah, it asks for the solubility.
Okay.
It's basically the same thing we just went through, right? First, write out your insoluble salt dissociation equation. What would you get here? 2Ag plus SO4 2 minus. Okay. You need to write these things. You must learn how to write these things yourself. Okay. And then you should know that your KSP is going to equals to the Ag plus square SO4 minus 2 minus first power. Okay. And you tell you the KSP value is 10 to the negative 5. Okay. And then once it says this, right, and it tells you, I'm going to put this insoluble salt in a solution, right? So every time you see this type of description, you know this solution must contain the common ions to your insoluble salt, right? And the solution you have here is actually AgNO3, okay? Which means that one will contribute to your Ag plus concentration, right? So if you look at this, since there's only one Ag inside your AgNO3 formula, therefore the concentration of this will be just 0.25. Okay? And then you want to actually start to put in your solubility terms. The ratio from here to here is 1 to 2, right? 1 insoluble salt produces 2 Ag plus, therefore you know you need to write 2S here and S for your SO4 2 minus. Therefore, your KSP can be written as 0.25 plus 2S squared times S. And this need to equals to the constant. Okay?
So it is exactly the same process we just went through, okay, in the previous question. Okay. So here, again, we're going to use small x
Approximation, right? So instead of calculating using this, we can rewrite this term as right. So we use the small x approximation. Okay, then you can calculate your solubility this way, right? So the solubility will equals to 1.9 2 times 10 to the negative 4. Okay. Okay, any question for this? It's basically the same question, just this one a little bit differently. Okay. And actually, different is actually quite similar. Okay, but just different substance. All right, the very last things we want to talk about for chapter 15 is this, right? There are certain insoluble salts. Its solubility will be influenced by the change of pH. Okay, so every time we say change of pH, what it means you throw in H plus or you throw in OH minus. Okay, and see how the solubility is going to change. And the things I tell you previous is that you always use the anion of the salt to make a judgment. Okay, if your anionic species in your salt is OH or a weak base, then when you blend into the acidic or basic solution, it's going to respond differently. Okay. If the anionic species you have is OH minus, meaning that once the salt dissociates, it's going to produce OH minus. Okay. If you add in H plus, we all know that H plus is going to consume the OH minus, right? But actually to keep the equilibrium the same, that means actually your insoluble salt will need to actually keep dissolving to produce more OH minus to maintain the equilibrium constant the same, right? So under this case, your solubility is going to increase. Okay. However, if you actually add in more OH minus, okay, then the solubility is going to decrease because you just have too much OH minus, right? So it's going to form more precipitate. On the other hand, if your anionic species is a weak base, when you add in a strong acid or you add in H plus, it's going to be consumed, right? So since your A minus got consumed to maintain the original status, your insoluble salt is actually dissolved more. Okay, therefore the solubility is going to increase. But if today you throw in OH minus, your OH minus doesn't kill your A minus. Therefore, there's actually no effect. Okay. There's actually another type of anion that we see, which is neutral, right? For example, the conjugated base of your strong acid, meaning there are actually 7 of it, right? For those 7 anionic species, they are neutral. Therefore, when you're in acid and in base, it doesn't really affect the insoluble salt solubility. Okay, so that's actually a basic concept that we should have. Okay. With this being said, then this question asks you, which of the following its solubility is going to depending on the pH? Okay, so this is actually a very standard way you're going to see in your midterm. Okay. So first set is you have NaF and NaCl, right? So the things that matters is actually your anionic species. So you have F minus and then Cl minus. Then you can actually know, okay, what kind of base, what kind of anionic species they are, right? F minus is a what? A weak base. Cl minus is neutral. How do I know? From its conjugated acid, right? The conjugated acid is HCl.
this one will be HF, right? HCl is actually a strong acid, therefore its conjugated base will be neutral. Okay. On the other hand, HF is a weak acid, therefore its conjugated base will be a weak base, right? So we just went through that the solubility is going to influence the species whose solubility is going to influence is the species contain either OH minus or A minus, right? So if you compare these two, apparently the answer will be this, right? Therefore your NAF will be the answer. Okay, second, anionic species will be NO3 minus and then NO2 minus. What's this? Is it neutral or is actually weak base? This will be neutral. How do we know? Because we know its conjugated acid will be HNO3, right? It's one of the big seven. Therefore, you know this one is neutral, so it's not going to be influenced by the pH. This one is the conjugated base of HNO2. This is actually a weak acid. Therefore, this guy will be a weak base. Okay. So this will be the answer you're looking for. Okay, the third question is the anion is OH minus and Cl minus. So I guess answer is actually very easy to select because if your anionic species is OH minus, it's going to be influenced by the pH, right? Cl minus, on the other hand, is actually the conjugated base of HCl. Again, it's neutral. Okay, so it's not going to be influenced by the pH. Okay. Very last one. NO3 minus and the Cm minus. Again, the NO3 minus is neutral, right? Therefore, the Cm minus, we know is actually a weak base. Therefore, it will be the answer. Okay, so that's pretty much the concept that you should have for this type of pH-dependent solubility type questions. Okay, any questions? No? Okay. Then we get back to this chapter 13 questions again. Chapter 14 questions again, sorry. So the question says, what is the pH of the resulting solution of 0.01944 mole of methylamine is added to 0.0351 mole of HCl in 60 ml of the aqueous solution, and it gives you a bunch of this question below. Okay. So what are we calculating? pH, right? pH of what? What kind of solution? It's not very clear, right? Because buffer. Okay. So once you do that, there's multiple combinations. There's actually different possibilities that you can have, right? You can either have buffer, you can have the rebate solution, right? We can have a strong acid solution. Okay, so how do you actually determine which is the one that we're looking for? Okay. So let's do some simple analysis. This one is your A minus, right? This one will be your H plus, right? So remember in the very beginning of today's lecture, I say, when you should write equations, yes, when the solution is mixed with strong acid or strong base, right? So what kind of solution doesn't really matter. But the key feature is that it says I'm going to add in a strong acid or in a strong base, right? So this is kind of the things that tells you, okay, right now I have strong acid adding in, right? So you can actually start in, once you have black clue, you can start to write this. Okay, so once you write this down, the next thing is actually want to actually calculate the moles that you have, right? And then to run the counter again to see who will be the survivors, right? So A minus, it actually already give you the mole, right? So that's very nice. Okay, and then your H plus is this. Okay, so once you know the moles, next thing is actually we run the counter again. Okay. Apparently your A minus is actually a lot more than your H plus, right? Therefore, all your H plus will be consumed. At the same time, you're going to produce a bunch of HA. Okay, so at the equivalent, at equilibrium, you are going to have 0.01593, and here will be 0.00351. Okay. So after this point, it becomes a lot more clear, right? The things that you have will be a solution because you have your conjugated acid and base with good amount, right? Therefore, you know you have buffer. Therefore, HH equation, EH equal to pKa negative log acid over base, right? You have Ka. You actually do give you Ka, so it's again very nice. So negative log 2.7 times 10 to the negative 11 negative log, okay? Most of your HA is 0.03, 0.00351, as it base is 0.01593. Okay, so you're going to get 10.57 for the first term plus 0.66. Therefore, your pH is going to equals to 11.23. Okay, so that is actually how you solve these type of questions. Okay, so any questions for this? So let me recap the logic of solving these questions, right? Again, when you read the question, you see you have a weak base, you have a strong acid, right? So once you see the strong acid shows up inside the question, trying to write an equation and run the again analysis. Okay, so you will know at the very end what other species that still exist inside your solution. In this specific case, you can see that you have conjugated acid and base coexist inside your solution. Therefore, you know you can actually use the HH equation to calculate your pH. Okay, so it's very simple. Okay, again, once you know what solution that you have, calculation-wise is, you know, simple things you can do. Okay, so I hope like all this practice help you to really see what solution that you have. Okay, so that's all the question went through for the midterm 2. Okay, any other questions? None, I guess we finished early today. Thanks, everybody. Oh, by the way, so all these things will be uploaded to the my YouTube channel. Okay. So again, like I said for many times, the most efficient way to prepare your midterm 2 will be go through all these in-person lecture videos. Okay. So good luck.
So I'm having a hard time